Hi! Today we're going to learn about calculating curl and divergence. So let's say we have the vector field y, z, x, and we have to calculate the curl and the divergence. So how do we do this? Well, let's first go back to our formulas that we know. We know that divergence is equal to the del operator dot the vector field and the curl is equal to the del operator cross the vector field. So before we even use these formulas, let's talk about what they mean. What this means is we're going to come out with a number. So divergence is going to be a number. The curl, on the other hand, is going to give us a vector. So curl of f is going to be a vector. So now let's do this. What is the del operator? Well, the del operator is just the vector. Del operator is just the vector the partial with respect to x, partial derivative with respect to x, partial derivative with respect to y, and partial derivative with respect to z. So, now let's use this to find the divergence. So this is going to be equal to the dot product of this with this. So we don't even have to write those two vectors out like that. Let's just write down the answer. So it's going to be d dx, the derivative with respect to x of y, plus the derivative with respect to y of z, plus the derivative with respect to z of x, which is equal to 0 plus 0 plus 0, which is equal to 0. So the divergence of f is equal to 0. So what does this tell us? Well, basically this tells us that the vector field doesn't diverge from a point. Now this doesn't mean that it doesn't converge, this doesn't mean that it converges to a point, but this means that it doesn't diverge from the point. So, now let's move on to finding the curl. We're going to have to erase this, so write this part in your notes. So, how do we do curl? Well, we have to cross the del operator with the vector field. So, to do that, let's set it up like this. Let's just put this on top of the vector field. Y, z, x. And now we have to cross them. So basically, we have this 3 by 3 matrix, so you can imagine the I, j, and k vectors on top. And we have to just use that to find the cross product. So it's going to be equal to, so this is going to be equal to, if we cover up this side, we have dy, the derivative with respect to y of x, so d dy of x minus the derivative with respect to z of z, so d dz of z. So we have that times I, the I vector, minus, if we cover up this middle portion, we have d dx of x minus d dz of y, and that's times the j standard vector, plus, if we cover up here, this one, we get d dx of z minus d dy of y times the k unit vector. So, what does this give us? Well, this gives us the vector. Here we have d dy of x is 0, minus d dz of z is 1. So we have negative 1, comma, d dx of x is 1, minus d dz of y is 0. So 1 minus 0, then we have to multiply that by negative 1 to get negative 1, plus ddx of z is 0 minus ddy of y, so negative 1 again. So the curl of f is equal to this vector, negative 1, negative 1, negative 1. So one thing that this vector can tell us is that it has a negative orientation, meaning that it rotates clockwise. We know this because all three terms are negative. And so that's just a known fact. If all three terms are negative, if all three terms of the curl are negative, then you know that it has a negative orientation and it rotates clockwise. If all three terms are positive, you know it has a positive orientation and rotates counterclockwise. Alright, so today we learned about how to calculate curl and divergence. Thank you for watching this video.